Hello there, how are you? Okay, I'll be explaining lessons on numerical analysis or numerical methods. Today we'll be talking on solving linear equations using Gauss-Jordan elimination method. As you know, in numerical methods we have different ways of solving linear equations. For today, this video will be talking about the Gauss-Jordan or the Gaussian elimination method. Let me write for you the title. Okay, so the title is saying Gauss-Jordan or Gaussian elimination method to solve simultaneous linear equations. I'll start with the example, which is x plus y minus z equal to 9, y plus 3z equal to 3, minus x minus 2z equal to. Okay, on this example, we need to solve this simultaneous equation, and as you see, it's a equation with 3 different variables and 3 different equations. So you need to change this into a matrix. You need to take the leading coefficient of each and every variable here. Okay. Well, the leading coefficient for this variable is 1, and here it's 1. Here you can see it's negative 1. Here you can consider that there is an x with a leading coefficient of what? Here I can consider that I have an x where its leading coefficient is 0, and here you can consider that you have a y with a leading coefficient of again 0, because I'm talking about 3 different variables. Okay, here I'll start. The leading coefficient is here. The leading coefficient is 1. Here the leading coefficient is 1, 1, minus 1. So I'll write here 1, 1, minus 1. And on this, and here in this place, you're going to write the right hand side. For the first row, it will be 9. Here, 0, 1, 3. And the right hand side will be again 3. Here, minus 1, 0, minus 2. And the right hand side is 2. Okay, the method that we're going to use here will be, you need to consider that there is a diagonal line drawn like this here. Consider that you have a diagonal line that's drawn in this way, and I'm looking for those numbers to be zeros. I want those to be zeros. The numbers that are below the diagonal line, those are supposed to be zeros. Okay, then let me start with solving this example. I'll write the matrix one more time. Okay, so here you have 3 rows. This is the first one. This is row 1, and this is row 2, and this is row 3. Once I start with row 3, first thing I'm looking for this to be 0. So as you know, you can relate the rows, row 1 with row 2 and row 3. You can relate any rows here in the way that can make the numbers 0. So here I will say row 1 plus row 3. This change will be for row 3, because here I have 1, here I have 1, and here I have minus 1. 1 and minus 1 will give me 0. So here row 1 is not changed. Write everything as it is. Again, row 2 is not changed. I'll write everything as it is. Row 3 is changed. So I will start R1 plus R3. Minus 1 plus 1 will be 0. 0 plus 1 will be 1. Minus 2 and minus 1 will be minus 3. 2 and 9 will give me 11. So now I have this 0. Now you can consider that this is my diagonal line. So what's left? It's left to make this 0. I need to change that to 0. So here I'm going to say minus R2 plus R3. This change will be again for R3. I'll multiply row 2 by negative, so that this will be negative 1 with this positive 1. I'll find here 0. So let's start. Row 1 will be as it is, 1, 1, minus 1, 9. Row 2 is again as it is. There is no change here. Let's start with row 3. 0 and 0 will be 0. 1, and don't forget that this is multiplied by negative. So 1 and negative 1 will be 0. Negative 3 and negative 3 together will be negative 6. Don't forget that this is multiplied by negative. So 11 and negative 3 will be 8. Now we're on the right track. You can see that those three numbers are now zeros. So now I'm going to say you have row 3. I want to make this one 1, so I will multiply it by negative 1 over 6. This change will be for row 3. Again, row 1 is as it is. Row 2 is again as it is. And row 3, 0, 0. Here, if I multiply this negative with this negative, it will be positive, and 6 divided by 6 will give me 1. And here, once I multiply it, it will be negative 8 over 6. But this negative 8 over 6 can be simplified, and here I can find negative 4 over 3. So this will be the value of the z, variable z equal negative 4 over 3. How could I know that this is z? If you remember, I told you that those are the leading coefficients of the x, and those are the leading coefficients of y, and those are the leading coefficients of z. So 1z, that means z. Z equal to what? Negative 8 over 6, which is simplified to negative 4 over 3. Okay. Now I will go to the original equations, which is x plus y minus z equal to 9. This is z. And here y plus 3z equal to 3. And here minus x minus 2z equal to 2. Okay. I can come to the second equation, this one, and I can say y plus 3z equal to what? Equal to 3. And here I'll plug in the value of z, which is negative 4 over 3. Are you understanding me? Okay, I hope everything is clear. This 3 will be cancelled with this 3. I can simplify it, so y minus 4 equal to 3. Move this one back. Y equal to 3 plus 4, where y equal to what? 7. Okay, now I get the value of the variable y. Now you can go back to the first equation, which is x plus y minus z equal to 9. Let me plug in the values of those variables. The y is 7 and z is negative 4 over 3. Now I'm left with x, and I'm looking for the value of this x, but I don't like working with those fractions, so I'll get rid of this fraction by multiplying both sides by 3. So once I multiply both sides with 3, 3 times x will be 3x plus 3 times 7 will give me 21, and those negative and negative I'll write here positive. And don't forget here that you can simplify. Here you can simplify. This 3 will be simplified with this 3, so it will be just 4 equal to 9 times 3 will be 27. 3x, 21 and 4 will be 25. Move this one back. 3x equal 27 minus 25. 3x equal 2. Divide both sides by 3, and here I can say that x equal 2 over 3. Okay. Those are the solutions for the 3 different variables. Those are the values. You can check your answer by plugging in those values in any of those 3 equations. I'm going to make for you another video with 4 variables. For now, this will be enough. See you.